Welcome to HB Tuners Subaru Training Part 25. In this training tutorial, we're going to be taking a look at the basics of boost control, understanding how a turbocharger works, understanding how a wastegate works, and then how a boost control solenoid can influence what the wastegate is doing to turn up or down our boost pressure. We're going to have a lot to cover. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with the fundamentals of boost control. This is going to be understanding how everything is going to be working mechanically with the actual turbocharger, the wastegate, and our boost control solenoid. Now, the first thing we need to talk about is how a turbocharged system works. It's actually pretty simple. Let's take a generic approach at this. Now, we have an engine, we have an exhaust manifold. In a non-turbocharged state, the exhaust manifold gets the exhaust gas out of the engine, it flows out the exhaust, and then it goes and dissipates into the atmosphere. Now, with a turbocharged engine, we'll have our exhaust manifold. That exhaust gas that's generated, the flow and the pressure, that'll go into a turbine housing. That's part of the turbocharger assembly. The turbine housing guides that exhaust pressure and exhaust gas, and it spins a turbine wheel. That turbine wheel is connected on a common shaft to a compressor wheel. The compressor wheel is housed in a compressor housing. What we'll find is that as we spin the turbine wheel faster and faster, on that common shaft, it'll spin the compressor wheel faster and faster. As a result of spinning the compressor faster and faster and having a higher shaft speed, we'll start to generate more flow through the compressor. It's going to be pulling the flow into the inlet of the turbo, compressing it, and generating that airflow in the housing itself, and then it'll discharge it through the outlet of the housing. Now, the outlet, we have charge pipes that connect to an intercooler. The intercooler connects to the throttle body. All of that airflow is directly generated and pushed into the engine. We'll find as a result, we're increasing the amount of air ingestion of the engine. If we have the proper amount of fuel and we ignite it at the proper time, we're going to make more horsepower and torque. Now, we need to regulate how quickly the turbine wheel is spinning, because if we start to spin it too quickly, it'll start to generate too fast of a shaft speed and spin the compressor too fast. That'll start to generate more flow and more boost pressure. We want to be specific of the power level of our engine at any given time. We don't want it to build unlimited amount of power. Let's just say that we're at 300 horsepower. All of a sudden, if we don't have any way to control that shaft speed, we might jump up to something like 700 or 800 horsepower. If we're on pumped gas fuel, our engine may not be able to handle it. We don't have enough octane. We could damage the engine. We want to be very specific of how we're applying and how we're working within this boost control routine here and regulating the turbine wheel. If we regulate it at a fixed RPM, we're able to then regulate the compressor spinning at a fixed RPM and therefore regulate the amount of airflow coming into the engine and boost pressure that we generate. So in order to regulate that turbine wheel or that shaft speed that we're building, we need a way that we can bypass the amount of exhaust flow and exhaust gas out of the turbine housing, go and let it go out into the exhaust stream, and being able to essentially stall out that turbine wheel. Get it up to a certain speed that allow us to generate boost pressure, generate airflow, additional airflow into the engine, but not allow it to go any further than that point. That's where a wastegate comes into play. Now, a wastegate is going to be bypassing the amount of exhaust flow and exhaust pressure through that turbine housing and not allowing it to spin that turbine wheel. What we'll find is, depending on what the wastegate spring level is going to be, what kind of spring is placed inside of the wastegate that we're dealing with, whether it's an internal or external wastegate, that'll be the boost pressure that we generate. That's going to be the lowest or the minimum. We can increase past that with the boost solenoid. We'll introduce that here in just a few minutes. Let's talk about internal versus external wastegates, understanding the fundamentals there, and then we can move into how the boost control fits into working with an external or an internal wastegate, because the configuration of the solenoid in terms of the lines, ins and outs of how we're manipulating the pressure will be different. Let's first talk about an internal wastegate. These are most common on OEM turbo applications. For packaging reasons, they're very simplistic. They do have limitations. We typically can't double an actuator spring level. So if the spring actuator inside of the internal wastegate is 8 pounds, we typically can't build much more than 15, 16 pounds. So there are limitations on how much we're able to get out of an internal wastegate. But for packaging reasons, they're very efficient, very tidy, and we're going to find that for an OEM, that's definitely something that they prefer to deal with. You'll probably almost never find an external wastegate on an OEM type vehicle. It's always going to be internal style wastegates. Now, the way this is going to work, on the turbine housing itself. We have a flapper door. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.